As promised, today we're going to look at some more complicated solving log and exponential equations. So we're going to start off with a couple of exponentials. If you take a look at the first one, it does look quite complicated. We've got e to the 2x minus 3 times e to the x equals 4. The problem with one is our first one has a power of 2x, and our second one has a power of just x, so they are not like terms. If you think about this in a quadratic format, which is the title of this one, you will hopefully recognize that pattern. We've got to the 2 power, and then we've got to the first power, and then we've got a constant. So if we subtract 4, we can have a quadratic trinomial. It's just an exponential form instead of the normal form we're used to seeing it in. So we're going to start by doing that. Another way to think about that first term is if we split up that power of a power, we would have e to the x quantity squared, which is twice as big, or the second power of that middle term, which gives us that quadratic trinomial. So we can actually factor this one. This one's a t-chart because the lead coefficient is 1. So if you think about this one, what multiplies to negative 4 are constant, and what adds to negative 3 the coefficient of the middle term? Well, the numbers that do that are negative 4 and positive 1. So I'm going to factor this one. It will be e to the x, because if you think about it, e to the x times e to the x gives you e to the x quantity squared, or e to the 2x, that's our first term, minus 4 and plus 1, just like normal, and we would get those middle terms when we FOIL. Now we've got a product equaling 0, so we can use our zero product property. So we set e to the x minus 4 equal to 0, and e to the x plus 1 equal to 0. So if we solve both the equations to get an exact answer, our first one, e to the x equals 4, so we take the natural log of both sides. Natural log of 4 equals x. This one, e to the x equals negative 1, so the natural log of negative 1 equals x. So those would be our exact answers, and if we want to punch those into our calculator, we can get our decimal approximations. So for our first one, natural log of 4, I got a decimal approximation of 1.386. For the second one, when you punch that in your calculator, you get an error because the domain for log functions is greater than 0 or positive. So this would be an extraneous solution. For our second one, same process. So we've got e to the 2x minus 5e to the x plus 6. So we need to figure out what multiplies to 6, adds to negative 5. So the numbers that do that are negative 6 and positive 1. Alright, so setting each of these equal to 0 again, we have e to the x minus 6 equals 0, or e to the x plus 1 equals 0, and hopefully you recognize that one already. Adding 6 to both sides on this first one, and taking the natural log of both sides, we get x equals the natural log of 6, or approximately 1.792. And the second one, of course, when we subtract 1 from both sides and take the natural log of negative 1, we get another extraneous solution. It's outside the domain of the log function.